So today we're doing unit 2.3 from the syllabus. That's absolute value equations. We've talked about absolute value a little bit in the first class. Today we're going to use it to introduce another type of equations, absolute value equations. So last time we talked about linear equations. Today we're going to talk about absolute value equations, which are slightly different. There's one little thing it's added to the equation, and that's the absolute value. Okay, first let's define. As always, we're going to define these equations, then solve them. So let's review the absolute value. So we saw before that when you have something like this, so those bars around -2 are called the absolute value. What's the absolute value of -2?
+2.
Exactly, +2. What's the absolute value of a number that's already positive?
It's always positive.
Always positive. Very good. So the absolute value always returns positive outcome or 0. Okay? So absolute value of something here could be is positive or sometimes 0. For example, the absolute value of 3 minus 3 is 0. But the absolute value can never be negative. Okay? It's always positive. It cannot be negative. Okay, so that's important. So we need to keep that in mind. That's going to help us throughout this absolute value equations. All right, so as an example for absolute value equation, it's always something like this. For example, okay, that's an equation because it has an equal sign. It's called an absolute value equation simply because it has an absolute value. Please mute your mic if you have noise. Right? Someone has some background noise. Please mute your mic. All right, so this is an example here of an absolute value equation. So there's always an absolute value symbol, and there is an equal sign. That's why we call them absolute value equations. So what this means is a number, actually let's not use 0, let's use, for example, 7, just an example. To solve this means to find the value of x. What number whose absolute value is 7? Number x, if you plug that number here,
7.
x could be 7. Or what else? What other number can you plug in and also get a positive 7?
-7.
Exactly. So x could be positive 7 or negative 7. Both of these, if you plug them here, the absolute value will always be positive. And that's basically an example of a absolute value equation. So we just solved it. We just solved this one. And we have 2 solutions for it. So the equation is not always this simple. It could be something like this. Let's say x plus 2 equal maybe 6. Here's another one. Again, we need to solve this. So we say a number added to 2, the absolute value of the sum is 6. What could x be?
4.
Okay, one of them is 4. Simply because if you put 4 here, 4 plus 2 is 6. The absolute value of 6 is 6. There is another solution, another value of x. If you plug it here, you will also get a positive 6 here. What is that number?
-8.
Very good. If you put -8 here, plus 2, would be -6, and the absolute value of -6 would be +6. So x could be -8. Okay, so this one also has two solutions. Again, simply because if you plug 4 here, 4 plus 2 is 6, the absolute value of 6 is 6. Also, if you put -8, -8 here plus 2 is -6. The absolute value of -6 will be 6. So that equation also has two solutions. What about this one? What do you think of this one? The absolute value of a number x is -3. What does that mean? Is that even possible?
No, it's not.
Why not?
Has to be positive or
Because the
negative.
absolute value is always positive.
Positive and zero.
Exactly. This basically goes against this definition. Absolute value is positive or 0. So basically, this is a contradiction here. It's like saying 5 equals 9. Doesn't make sense. Same thing here. So we say no solution here. There's no number you can plug to get a negative value because the absolute value is always positive. Someone has, I hear your mic. Mic is noisy, believe you, Laylanet. If you can maybe not touch the mic or push it away from you a little bit, you can hear it.
Oh, it's not me, Professor. I'm not touching the mic right now.
You don't have a microphone? Okay, I hear someone's mic being like noisy. All right, so we said this one has no solution. Same here, if you, I don't know, if you do this plus 5, -1. Same here, same thing. This can't be true because the absolute value can never be negative. So absolute value of whatever is inside could be any expression. It cannot be negative. Regardless of any numbers you can plug, you will never get a negative value from an absolute value. Same thing here, so we say no solution. Okay, no solution, just like the previous one. Another case is, what if you have absolute value of x is, let's say, 9. What do you think x is? Not 9, actually, maybe, let's use 0 instead. What's the absolute value of x is 0? What could that be? What is x?
Would it be 0?
That's right, it could only be 0. So, because absolute value of 0 is 0, as we saw earlier. So, it's basically all the possible cases. You could have a positive number here. If you have a positive number, as you can see, because the absolute value is always positive, you get two solutions. Two solutions here, two here. If you have an absolute value that's equal to a negative, there is no solution, none. Okay, but if it's 0, if you have 0, if the absolute value equals 0, you have exactly one solution. So x is 0. Okay, and it could also be something like this. X minus 3 is 0. What could x be here in this case? X minus 3 equals 0. That means x is
3?
That's right. X can only be 3. That's the only number that could give you 0. So x is 3. Because 3 minus 3 would be 0. The absolute value of 0 is 0. So that's basically how absolute value equations work. Okay, just watch out for the sign of the number that's equal to the absolute value. So you may have two solutions if it's positive, no solution if it's negative, or one solution, exactly one solution if it's equal to 0. Okay, let's summarize all these now in these three different cases. So basically, this is the standard form or the general form of all the absolute value equations. So it's usually something like this: some ax plus b inside, equal sign, and then some number. For example, k. K here, for example, 0, -1, 6, and so on. So that's basically the, like I said, the standard or the general form of all the absolute value equations. Sometimes it could be numbers before the absolute value or after the absolute value. But when we simplify it, when we isolate it, you end up with something like this. If you have, for example, a number here, +5, we can move the +5 over, combine it with k to get this form. So based on the sign of k, we determine how many solutions the equation will have. For example, so here's the first case. If k is 0, or actually greater than 0 or positive, so when k is greater than 0, that means it's positive. So for example, 1, 2, 3, 4, and so on, 6 here, 7. How many solutions again do you have when k is positive?
2.
Very good. So that's right. So as you saw here, whenever this is positive, you expect 2 solutions because again, the absolute value is always positive. So you end up with 2 solutions, just like x here, for example, equals 7. X could be 7 or x could be -7. So 2 solutions. So whenever you have a positive number, it's 2 solutions. So k, k greater than 0. This means basically k is positive. Okay, k greater than 0 means 2 solutions. What if k again was negative? What if k here, so we have a negative number, for example, -1, -3, how many solutions that is?
It would be no solutions, right?
That's right, would be no solution. So k negative or less than 0 means the same thing, okay? K negative or less than 0. So that means no solution. What's the third case? What's the third case here? K greater than 0, k less than 0, and third one is k is?
Equal to 0.
Equals to 0.
That's right, k equal to 0. In this case, how many solutions do you have? How many solutions when we have? Say it again?
Is it 1?
1.
That's right, 1 solution. And that pretty much sums up. That pretty much sums up all these cases. So this is what you need to keep in mind. So whenever you deal with absolute value equations, keep in mind the absolute value is always either positive or 0. So if it's positive, you have to find 2 solutions, not just 1. So you gotta find both to get full credit. If it's negative, you don't have to do anything, just say no solution. You don't need to explain it. You can say what you don't have to. And third case, if you have 0, then you're looking for exactly 1 solution. So basically when you have 0 here, just ignore the absolute value. Just solve it like you solve the linear equations that we learned last time. So if 0 here, just ignore these and just solve, remove them and just solve like you do normally with linear equations, first degree equations. All right, let's do more some more examples. We're gonna try to make the equations longer, requiring more steps. Let's say x plus 2 minus 1 and 7. All right, so the absolute value of x plus 2 minus 1 equal 7. By looking at it, you might think, or you might already know, determine how many solutions we're gonna have. How many solutions do you think we're gonna have?
2.
Okay, probably 2, but this is not k yet. You see this number 7, it's not k, because the equation has to be in this standard form. That means the absolute value must be by itself, isolated, then the number here would be k. But for now, this is not k yet because we have the absolute value, it's not isolated, it has a number next to it. So we need to first isolate this. Isolate the absolute value, then what we get here will be k. First, we need to get rid of the -1 to keep the absolute value by itself, like the standard form says. All right, so what do you think we do here to cancel this -1 again?
Add 1.
That's right, just need to add 1. Just like we did last time with first degree equations, now we end up with as you can see, now with this is k, okay? This wasn't k in the beginning because the absolute value wasn't by itself. After you isolate it, it becomes like this. Only the absolute value on one side, no numbers before or after. That's when you say that the number on the other side is k. So here, that's k. Now, based on this k, how many solutions are you gonna have?
You can have 2.
2 solutions. So k equals 8. That's greater than 0. That means we're going to have 2 solutions. It might not be as easy as the ones we saw before to get the solution, but luckily we have some specific steps you can follow to find the 2 solutions. So here's what you do. So you take this, after you isolate the absolute value, we're going to turn this into 2 equations, 2 linear equations without the absolute value. And then we're going to solve them. We're going to solve those 2 equations to get the solutions earlier. Okay, so after you isolate the absolute value, so here's what you do. You write 2 equations without the absolute value. Just say x plus 2 equals 8. Basically, that's a positive 8. And then you take the same equation, you write it again, but you turn this positive k, you turn it into a negative k. This turns into x plus 2 minus or negative 8. That's the key here. That's exactly how you get those 2 solutions, because the equation can be very long and it might not be as easy to see the solutions. But if you can see the solutions right away, that's fine. One obvious solution is, what is one obvious solution for this one? X plus 2 is 8. That means x is?
6.
That's right, that's one of them. And there's another one that will also give you positive 8 here. What's that number? What's that x? Negative 10, right?
Negative 10.
That's right. If you put negative 10 here, plus 2 will be negative 8 inside. And the absolute value of negative 8 is positive 8. But again, you don't have to guess those numbers. You don't have to do them like that, figure them out mentally. There's actually specific methods to find them. All you have to do is take the equation, turn it into 2 equations, drop the absolute value, and then just solve both of these equations. So here, so now we end up with 2 first degree equations, just like we solved the last time. So let's solve this. So minus 2 on both sides. X is 6. And here, minus 2, also minus 2. So x is negative 10. That's why I said earlier negative 10 and we said 6. That's exactly how you get these numbers. Again, you don't have to guess them. Just write the equations and solve them. Okay, does that make sense, everybody?
And yes.
The room, let me hear from all of you.
Yes.
Okay, so
Yes.
Yes, yes.
Yes.
all right. So let me know at any moment, please. If something's not clear, let me know and stop me to explain it again. All right, let's see another example here. Let's say 2x minus, for example, 11 plus 4. Just by looking at this, do we know how many solutions yet we're gonna have?
No.
We don't know yet. Again, this is not k. So this may look positive, but doesn't mean we have 2 solutions because this is not in standard form. It has to be like this. Only the absolute value by itself. Only the absolute value by itself and k on the other side. So what do you think to do? What do you think we need to do here in order to write this in standard form? What do you do here to get this in standard form? Basically, we want to isolate this. We want to get this by itself, the absolute value. What needs to be canceled?
4.
The 4
The 4.
minus 4 on both sides.
That's right. So this is not k yet. It's positive, but doesn't mean we have two solutions. We still have to isolate it. So isolate. So we need to isolate the absolute value first. To get k. So 2 minus 4 here, minus 4 on this side. We end up with what? 2x minus 11 equals 1, take away 4. What's 1 minus 4? 1.
Negative 3.
That's right, negative 3. Now that's k, okay? Because we have the absolute value. So we can call this k. And how many solutions we can have?
No solution.
Exactly. So once you isolate it, as you can see, k is negative. So no solution. Okay, so before you do anything, make sure you isolate your absolute value before you judge k. K is when the absolute value is by itself. If it's not by itself, then that's not k. That's just some random number. For example, here you have 1. It may look like k, it's positive. You may say it's two solutions, but as you can see, once you isolate it, actually it turns a negative, and there's no solution. Let's do another one. So let's say we have x, 2 times x. And maybe some number. And probably 5 here. Again, we don't know how many, whether we have solutions or not, because this is not in standard form. So standard form, we need to get this absolute value by itself on one side. We need to isolate the whole thing. But most importantly, do not distribute. These are not parentheses. Okay, do not distribute right away. If you distribute right away, you're looking for only one solution if there is one. Or you might be looking for a solution that does not exist. For example, if this turns out to be to have a negative k, then there is no solution. But if you start multiplying right away, you basically assuming there is a solution, and you try to solve for that solution, you might be just wasting time finding something that's not a solution to the equation. So do not distribute, instead isolate. Okay, so do not distribute this. Very important, because I will only give you one solution. And now, how do you isolate this? What do you do first?
Positive 1 on both sides.
Right, so first you want to cancel this negative 1. Later, we're going to cancel the 2. So let's cancel the 1 by adding 1 to both sides. So this turns into x plus 1. And of course, these cancel, so end up with 6. It's not isolated yet. We need to get the absolute value by itself, so we need to cancel the 2. How do you cancel the 2?
Divide.
Very good. Yeah, we need to divide because this is a multiplication here. It's 2. Just like with the parentheses, this means a multiplication. The opposite of multiplication is division. So we're going to divide by 2 on both sides in order to cancel this 2. Not subtract 2, but do the opposite. We do that when you have a number by itself. But this is a multiplication, so we divide. So we end up with x plus 1 and 3. Is it now in standard form?
Yes.
Yes.
Right. So we have x plus 1 equals 3. That's k, that's positive. So we have two solutions. So that's when you drop the absolute value and write two solutions. One, what's the first equation?
X plus 1 equals positive 3.
That's right. So you're going to write two equations with this one without the absolute value, but one with positive k, the other one with negative k. So positive 3 and x plus 1 is negative 3. You solve each one, so x is 2 here, and here x is negative 4. And you can easily check, you can take these, plug them into the equation, use the order of operations to simplify, and check for your solution. Okay, so always make sure you isolate the absolute value. First, once you get it by itself equals a number, based on that number, if you end up with a negative number here, you stop, no need to solve, you say no solution. If you end up with 0, you have exactly one solution. If you end up with a positive, turn that into two equations and solve them. Okay, everyone, does that make sense? Any questions?
No questions.
All right.
Professor, I had got disconnected. I could always go back and watch it, right?
Okay, yeah, I'll post this. I'm recording it, I will post it.
Yeah, because I got disconnected.
So let's do another example here. So now we're gonna look at something a lot of interest in here. Sometimes you may get this. You may get something like this with two absolute values, not just one, two of them. So here's what you do. It's pretty simple here. You're just gonna take this and turn it into two equations without the absolute values. So all you have to do is just drop all the absolute value altogether. Just like we did, we dropped the absolute value and we wrote one equation with positive here and the other one with negative. We're gonna do the same thing. We're gonna drop all the absolute values. We're gonna write one equation with positive this and the other one with negative this. This is basically k. Okay, this side is basically k. We're gonna write 3x minus 1 equals positive whatever this is. Just like here again, we wrote positive 3 and here negative 3. So it's gonna be plus 2x minus 4 or plus 4. Notice that I'm no longer using absolute value. These are parentheses because I dropped all of them. So we need one with positive. And then we're going to take almost the exact same thing, but we're going to turn this into negative, just like we did with positive 3 and negative 3. This will be 3x minus 1 equals, so the only thing that changes is negative. This positive turns into a negative 2x minus 4. And that's pretty much it. That's the most important step here. The rest we already know how to do. These are just simple first degree equations, just like we solved the last time. We solve them and we get to solutions. Okay, so be careful with this negative here and this negative here. I mean positive here and negative. That's all you have to do. Again, so if you see two absolute values, just drop all of them and write the equation twice. Once with this positive here, and once with a negative of k, or the opposite. You can also write this twice with a positive this and negative this. Either way will be the same. Okay, so let's solve this. We saw how to do this last time, so we're going to simplify each side. So basically, technically, when you distribute the plus, it doesn't change much. What do you do now to get the x? Remember last time? So we simplified this, we simplified this. What do you do now? So we could get the x by itself.
Add the 1.
Minus 2x on both sides.
That's right. We're going to move the 2x over here. We're going to move the negative 1 to this side. So we can have the x's on one side. So 3x, 2x moves over, becomes negative 2x. And negative 1 moves over, becomes positive 1. And bring down the positive 4, it doesn't change. So this is basically x for 1x is 5. That's one of the solutions. The other one, same thing. This time, be careful, we have a negative, so we're going to distribute that. That will change both of these signs. Here, the plus didn't change anything, but the minus will. Negative 2x and positive 4. And again, we're going to move the negative 2x over, negative 1 to the other side. So it will be 3x minus 2 or positive 2x. And when we move this over, the sign changes because we moved it across the equal sign. Negative 1 again turns into a positive 1, a positive 4. This is 5x plus 5. That means x is 1. You have your two solutions. Again, feel free to plug them. You'll see that you get two equal sides. Okay, that's the important thing about when you see two absolute values. The first and the most important step is, again, remove all the absolute values and then just solve, and you'll get two solutions. Okay, did that make sense, everybody?
So I have a question. In the second equation,
Mhm.
so you put the minus in front of the parentheses of the 2x. Do you change the sign in between also?
Which sign in between? This one?
So in the original equation, it was 2x plus 4.
Okay, I see what you mean. No, I shouldn't change.
Oh, okay. So it should be 2x plus 4 in that one also?
That's right. This should stay exactly the same. I don't know why I wrote a positive, but thank you for finding out. So this should not change. We're only changing the sign in the front. One with a positive, one with a negative. So let's fix this. Negative is here. So it should be a negative here. That's right. Things will change a little bit. And then this moves over, becomes positive. So this one here is a negative. Okay, that was my mistake. So now, what would the x be?
Minus 3.
That's right. And then divide by 5, divide by 5. So x is negative 3 over 5. It's fine to have a fraction as a solution, just try to simplify it. And that's basically the solution, okay? So keep everything the same, just drop the absolute values, all of them, and one equation will have a plus, one equation will have a negative here, but make sure you put the parentheses, okay? We drop the absolute values. These are just regular parentheses, so we distribute if we have something in front of them.
Professor, I'm a little confused on the last one that you just did. How, when you bring the like terms over, how did the negative 2 become a positive?
Yes, so when you move something over across the equal sign, the sign changes. Okay, when you move, or if you want, you can do the regular way. You can do plus 2x here and plus 2x on the other side. Okay, so we talked about in detail last time. So whenever you move something across the equal sign, change that sign. If it doesn't move across the equal sign, just within the same side, the sign doesn't change. Okay, everyone, makes sense?
Yes.
Okay, very good. So we're going to continue on now on the discussion board. Let me see, take a screenshot of the attendance here. I haven't taken the attendance yet, so we're going to move over to the discussion board and show you the lesson plan, and we're going to make a new thread and do a bunch of things there. So please head over to the discussion board and continue with this. Rewatch this later, and if you have any questions about it, please let me know.